Welcome to this explainer. Okay, today we're diving into a really rigorous breakdown of Lesson 3 from our Mathematical Mastery program. Everything we've covered up to this point, all the arithmetic, the basic number rules, it's all just been preparation for right now. Today, we're treating algebra not as some random guessing game, but as a series of beautifully structured, repeatable logic puzzles. By the end of this session, I promise you, solving linear equations is going to feel like second nature. Here's our roadmap for today. First, the core foundation. Then, two-step equation mastery. Next up, conquering brackets and fractions, followed by translating words into equations. And finally, the ultimate failsafe, substitution. Let's get right into it. But before we build, we really gotta ask a pretty critical question. Is our foundation completely solid? Like, are you truly ready for real algebra? Because everything you've learned previously about BODMAS, the order of operations, and dealing with directed or negative numbers was just training for this exact moment. Our sources emphasize that a student who is even a little shaky on directed numbers will end up making silent sign errors in every single algebra chapter for the next year. And we definitely don't want that. To put that into perspective, consider a 10-minute cold diagnostic test. It brilliantly illustrates the exact prerequisite knowledge we expect. We're talking about things like -7 plus -4, or expanding -2 times x minus 5. If those kinds of questions aren't completely automatic for you, without reaching for a calculator, you aren't quite ready to move forward into equations. You really have to earn the right to move on by mastering that basic arithmetic first. All right, Section 1, the core foundation. Assuming you pass that diagnostic test with flying colors, we are now going to establish the absolute non-negotiable law of the algebraic universe. Read this mantra, internalize it, literally say it out loud. An equation is a balance. Both sides are equal, and they absolutely must stay equal after every single step you take. Whatever you do to one side, you do to the other. No exceptions. Just look at how cleanly this golden rule works in practice. In the equation, x plus 5 equals 12. Our ultimate goal is to get that unknown variable, x, entirely by itself. So, how do we remove that positive 5? Well, by subtracting 5, right? And this is crucial, to maintain our perfect balance, we strictly subtract 5 from both sides of the equation. X plus 5 minus 5 leaves just x. On the right side, 12 minus 5 leaves 7. Therefore, x equals 7. Simple, right? And listen, this isn't just a rule for addition and subtraction. Whether you're adding, subtracting, multiplying, or dividing, the standard remains uncompromisingly clear. Always balance the scales. If you have x minus 3 equals 7, you add 3 to both sides. If you have 3x equals 21, you divide both sides by 3. And if you've got x divided by 4 equals 5, just multiply both sides by 4. Whatever the operation happens to be, you just apply its exact opposite to both sides of the equal sign. Moving right along, Section 2, two-step equation mastery. Now that we're escaping those one-step problems, let's see what happens when we escalate the challenge to equations with a two-step structure. Honestly, mastering this is wonderfully logical. It is simply doing BODMAS in reverse. When calculating numbers normally, we multiply and divide before we add and subtract. But when we're unraveling an equation, it's a perfectly repeatable two-step procedure in the reverse order. Step 1, undo any addition or subtraction. Step 2, undo any multiplication or division. Take example 1, for instance. 2x plus 3 equals 11. Following that reverse BODMAS strategy, we first undo the addition. We subtract 3 from both sides, which perfectly balances out to give us 2x equals 8. And boom, now we're back to a simple one-step equation. We undo the multiplication by dividing both sides by 2, revealing that x equals 4. Okay, let's turn up the heat a bit. Section 3, conquering brackets and fractions. So that handles standard equations. But what happens when the curriculum throws a curveball, complications like brackets and fractions in our path? The trick here is that we don't actually need a whole new set of rules. We treat brackets and fractions merely as obstacles to be systematically dismantled, bringing us right back to our safe, comfortable two-step foundation. If you see a bracket, expand it first. If you see fractions, treat them like a messy room. Clear them out immediately by multiplying absolutely every term by the lowest common multiple. Once those obstacles are gone, you just solve it like normal. By aligning the left and right sides side by side like this, we can prove that even with a fraction, the equation remains a perfectly leveled scale at absolutely every stage of the breakdown. Say we start with x over 3 plus 2 equals 9. First up, we undo the addition by subtracting 2 from both sides, which leaves x over 3 equals 7. Then, we dismantle that fraction by multiplying both sides by 3. The result, x equals 21. See? No magic, just pure logic. Next up, Section 4, translating words into equations. Word problems, yeah, they often intimidate students, but they really shouldn't. Fun fact for you, René Descartes is largely credited with introducing x as the standard symbol for an unknown way back in the 17th century. And once you boldly declare your unknown as x, and then just map the English sentence directly to mathematical operations, the entire mystery completely evaporates. Define what you don't know, and the rest just falls into place. Just look at how direct this translation is. A number plus 5 is 12 maps precisely to x plus 5 equals 12. 2 times a number plus 3 is 11 translates flawlessly into 2x plus 3 equals 11. It's almost like learning a super straightforward language. Once translated, solving a word problem requires absolutely zero new skills. Structurally, it is identical to solving the mechanical equations we just mastered. Finally, Section 5, the ultimate failsafe, substitution. All right, let's unlock what is basically the ultimate cheat code of algebra. Our sources are incredibly strict on this point, and for good reason. Every single solution gets checked by substitution. Now, I know what you might be thinking, but this is not optional busy work. It is the single fastest way to catch your own mistakes and guarantee your marks before you even hand in the paper. By substituting your answer back into the original equation, you literally become your own examiner. Let's actually put this failsafe into action. We solved an equation earlier and found that x equals 4. So, to verify it, we just substitute x equals 4 back into the original 2x plus 3 equals 11. Just a quick reminder, always use brackets when substituting. 2 times 4 is 8. 8 plus 3 is 11. By proving that 11 equals 11, we are confirming absolute mathematical truth. If those numbers didn't match, we'd immediately know we made a mistake and could go back and fix it right then and there. Wow, we have covered a tremendous amount of crucial ground today. So I'm going to leave you with this final mental challenge just to test out your newly forged skills. Think about the equation 4x minus 9 equals negative 5. Can you mentally solve and check this? Undo the subtraction, undo the multiplication, balance the scale, and then substitute your answer back in to be absolutely sure. If you can master this fundamental balance of algebra today, just think about what other incredibly complex systems in the real world you're now equipped to decode. Thank you for joining this explainer. Keep practicing, always balance your scales, and I'll catch you next time.